Okay, AP Chemistry students, this is the periodic table of elements we're going to be talking about today, and this is video number 3 for summer assignment. So let's jump right into this and kind of talk about the periodic table, what's going on, and talk to you about how the periodic table that you see on your screen right now is different than the periodic table that you're going to be using for this class. So we're going to use this right now because it's good to show some of the groups that are going on in the periodic table. But then we'll take a look at what the periodic table that we're going to be using in our classes. So first off, a couple big designations in between on the periodic table. We could draw in right here that stair-step line. If we remember from regular chemistry, it kind of goes just like this. And that stair-step line is going to separate our metals, which are on this side of the stair-step line, from our non-metals, which are on this side of the stair-step line. And then there's some other designations as we need to know as well. So that's our big one. And the metals are included in our intertransition metals down here, these guys. So we're going to include those in our metals as well. So it's our big designation. Okay. Then we're going to start taking a look at our columns, or we call them groups. And here we have group 1A on the periodic table. And we're going to call these guys the alkali metals. And as you can see, they're kind of this sort of salmon color. These are our alkali metals. And notice hydrogen is not included in there. Hydrogen is a non-metal for all intents and purposes, even though it has one valence electron. We do group it over here with our non-metals. And because it mostly covalently bonds, and we'll get more into that later on. But you definitely need to know that the 1As are alkali metals. Here we have our 2As, which is our alkaline earth metals. These are 2As. In the center of the periodic table, here, including, we'll go all the way across to here. These are all our transition metals. And oftentimes these transition metals are characterized by having multiple charges when they form ions, except with a couple exceptions that we'll take a look at later on in this class as well. But those are transition metals. Down here below our stair-step line, we have some elements that act a lot like transition metals, things like lead and tin. This kind of light yellow color, maybe a little darker yellow color than the transition metals. We sometimes call them other metals. They're still going to behave like a transition metal though. Attached or touching that stair-step line, we have boron here in green, silicon, germanium, arsenic, antimony, beryllium, polonium. These guys are going to be our metalloids, and sometimes also called semimetals. So metalloids or semi-metals kind of used interchangeably. Here in 7A, you probably remember these are our halogens. 7A group, fluorine, chlorine, bromine, iodine, acetine. And of course in 8A, we have our noble gases. So you should be able to identify an element based on its positioning in the periodic table, which is going to tell us a lot more later on. And of course down here at the bottom, we have our intertransition metals with our actinide and lanthanide series. So I mean, a test question might say something like, how would you categorize, let's say, chromium? And so you would find chromium. Chromium's right here on the periodic table, and so you would say, okay, chromium is a transition metal. And so when we get into nomenclature and writing formulas, that is a tip-off that there might be multiple charges going on, or multiple oxidation states, as we call them. A couple other things that we need to remind you of from regular chemistry, and I kind of alluded to this already, but groups or families, which are vertical columns on the periodic table, like an alkali metal, alkaline earth, halogen, noble gas, things like that, we call those guys groups or families, and these are vertical columns. And we also know that these guys do have similar chemical and physical properties. Similar chemical and physical properties. For example, lithium here, our alkali metal, if we drop it in water, it's going to react with water to liberate hydrogen gas, and some lithium hydroxide is made. And that hydrogen gas is really flammable, and it often will spark and explode. Well, sodium does the same thing. We drop it in water, same exact thing, a little bit more vigorous reaction, liberates hydrogen gas, forms sodium hydroxide, sparks, explodes possibly. Potassium, the same exact thing. So they all really, and they're all metals. So they all behave very similar. Periods are horizontal rows on the periodic table, and this is our increasing, they're characterized by increasing atomic number, which will be the focus of our next video. But we could tell periods, they're actually usually numbered on the periodic table. So hydrogen up here at the top would be in period 1 along with helium. Lithium and beryllium straight across to boron, carbon, nitrogen, and oxygen would be in period 2. Sodium and magnesium and aluminum, phosphorus, sulfur, silicon, those are going to be in period 3, and so on and so forth. Now let's get into looking at what the periodic table looks like for AP chemistry. And this is our periodic table for AP chemistry. So one of the things that you might see that stands out on the periodic table for AP chemistry is it does not have names. Periods are not labeled. Group numbers are not labeled. So there's not a lot of labeling on here, but we need to still be able to be familiar with this, to use this and do what we need to do with it. So one of the things that we really need to realize is that, again, there's no names. So if I ask you, write the formula for magnesium chloride, you definitely need to know that there's your magnesium and there's your chlorine, and you definitely need to know how to look up charges and crisscross charges, and we'll get to that in another video. That'll be video 5, I believe. So what do you need to know? Do you need to memorize the entire periodic table? And the answer is you do not need to memorize the entire periodic table. What you do need to know is you need to know the names and the symbols of quite a few of the elements on the periodic table. So you probably from regular chemistry know a lot of this already. You should know all of your alkali metals. So if I ask you, what is Rb, atomic number 37 down here, you should know that's rubidium. Or what is atomic number 56 Ba, you should know that's barium. So you should definitely know all of your names of your alkali and your alkaline earth metals, 1A and 2A. Going across into our transition metals, you should definitely know your names of all, at least this first period of transition metals. Definitely know all of your nonmetals here, including your noble gases. So, and then all of our halogens we definitely need to know. Aluminum. Looks like well, maybe you do need to know most of them. Okay. And then as far as your transition metals, going back to your transition metals, there's quite a few in here you definitely need to know that come up over and over again in AP chemistry. Definitely know Ag is silver, there's cadmium and mercury, there's gold, platinum, and some of these other ones are kind of some random ones that do come up. You should probably, commit them to memory. And there's a few down here in our actinide series that you should probably take a look at and know. Those are the really, really common ones that are going to come up in AP chemistry, although an occasional molybdenum might get thrown out there, a tungsten or something like that. So be familiar with these. If you don't remember, for example, what this is, definitely commit it to memory. If you don't remember what potassium is, commit it to memory, or iodine, or selenium, or gallium, or things like that. Okay, so that's today's video on the periodic table. We'll be getting into in the next video calculation of protons, neutrons, electrons, and isotopes, and average atomic mass. But definitely know for this video your groups, your periods, and how to distinguish between groups on the periodic table.